Example 2. It says angles with terminal sides on the coordinate axes are termed quadrantal angles. Excuse my vocabulary there. In the case of these angles, ratios with x equals 0 or y equals 0 in the denominator are undefined. So they've kind of already given us part of the answer here, but we're going to work through it so we can really understand what's going on. Okay, so it says find sine, cosine, and tangent for when our angle is equal to 90 degrees. So what does that mean? So I can sketch this thing out. If we were on the quadrant plane, where's my pen? There we go. So if I were to sketch this thing out, we would know that the 90-degree angle would fall exactly on that y-axis, right? So at that point, I could say that maybe x is equal to 0 and that y is equal to 1, possibly, right? So if that's true, then my r, it makes sense that if my y is equal to 1, then the radius must also be 1 if we're drawing a circle there, okay? So let's take that information and let's find sine, cosine, and tangent. So sine, we want to find sine of 90 degrees. And we understand that sine is equal to y over r. So if I take my values there and I substitute my y and my r, I get 1 over 1, which is equal to 1. And then we're going to find cosine of 90. And cosine, again, is x over r. Well, in this case, we chose, if it's on that y-axis, x is going to be 0. And my r is 1 if we're looking at the unit circle. And what that gives us is a value of 0 for cosine of 90. But now look at tan. We can go back and let me pause here and say, if you remember the domain of tan, we should understand that the tan of 90 degrees is undefined, and we already talked about that because we can't have 0 in the denominator. And this is just reiterating that if we take these values and we substitute them in, we get 1 over 0, which is undefined.